What is the effect of dry ice in 4 different liquids?
Today we are finding out, plus doing a few other cool carbon dioxide experiments. Welcome back to Destructive Creativity. We exist for you, for science, and for fun. So, if any of those things appeal to you,
click the subscribe button and like this video.
Right, it really helps us out. So today we are testing the effects of dry ice in 4 different liquids. Specifically, those liquids are water, alcohol, oil, and acetone. And they all have different viscosities, surface tension, and vapor pressure. And each of those has an effect on what's going to happen. It's going to be really cool.
So we all know what happens when you add dry ice to water. Clouds of billowing smoke come out.
Now, the visible part of this cloud that you see isn't the carbon dioxide gas that is being sublimated by the dry ice pellets. What you're seeing is water vapor, because water has a fairly low vapor pressure. So that got me thinking, what is the effect of dry ice in different liquids? Because this effect that we see right here, that's only because of water. So let's test it out.
First, let's add some water and drop a dry ice pellet in and see what happens.
Very cool. So you can see the dry ice sublimating, which means it's turning from a solid into a gas, directly skipping the liquid stage. And as it's going through the water, it rises in bubbles fairly quickly and releases mist. And that mist is water vapor. That's fairly straightforward. Next up is vegetable oil, or canola oil. So now canola oil has more viscosity than water, but a much, much higher vapor pressure, which means that this probably isn't going to turn into a mist at all. All right, let's see. Oh, cool. Yeah, so there's there's no mist whatsoever, which means those bubbles that are coming up are just carbon dioxide gas. The bubbles are slower slightly. Very cool. Now at the end here, we're going to line up all of these together, and we're going to see how long an equivalent size of dry ice takes to sublimate, so disappear completely. Because I suspect that the vegetable oil, because it has a higher viscosity, it's going to allow an insulating layer of gas around the dry ice pellet, kind of like the Leidenfrost effect that we covered a couple of weeks ago. And that's going to insulate the dry ice pellet and last a lot longer than, say, in water or acetone. But for now, that's really cool.
Next, we have isopropyl alcohol.
Okay, so isopropyl alcohol is very less viscous. That's bad grammation, but whatever. Okay, whatever. Here's isopropyl alcohol with a dry ice pellet. Ooh, there's a lot of vapor there.
Cool.
So that vapor is actually alcohol vapor. There's no water there.
Huh.
Fascinating. And look how fast the bubbles are moving up, especially compared to the vegetable oil. So because vegetable oil and water are much more viscous than isopropyl alcohol. Remember, viscous, essentially, if you use the word friction instead of viscous, that kind of gives you the idea. Because there's less friction in the isopropyl alcohol than the vegetable oil or the water, which means the bubbles can move up faster through it. It smells funny over here. That's cool.
It is cool.
So that's alcohol vapor. I didn't think that there would be this much vapor. There's actually more vapor with this than the water, I think. Which doesn't make any sense to my head because alcohol has a higher vapor pressure than water, I believe. But whatever, we will examine our results after. Next up will be acetone. And acetone is essentially one step farther than the isopropyl alcohol. If vegetable oil is thicker, more viscous than the isopropyl alcohol is more viscous and thicker than acetone. Try this here. We have a dry ice pellet
Come on.
in acetone. Holy
Wow.
smokes. Okay.
Okay.
There we go. So the dry ice pellet is already gone.
bubbly.
It's bubbly. Wow, that was almost a violent boil. That is really cool. I'm glad that we were able to do this and to see the correlation between like the sizes and shapes of the bubbles and all of the different variables of the different liquids like the viscosity, surface tension, and vapor pressure. That's really cool.
Yeah.
One thing that I'm not entirely sure about, which I'll have to come and revisit maybe a little bit later, I'm using 70% isopropyl alcohol. I'm pretty sure the vapor, the clouds that are coming off of the isopropyl alcohol is still water vapor, because I don't think alcohol vaporizes quite that easily. But I'll have to do some more research on that. Anyways, this is Destructive Creativity. Thanks for watching. We have new content coming out every single week for Destructive Creativity. I'm Jonathan.
And I'm Eliana.
Till next time.